when you actually look at the clinical studies I mentioned before, in 2019, I think it was, there was a meta-analysis of 18 clinical studies, no effect of soy or isoflavones on the two main thyroid hormones. As far as I can tell, the thyroid issue has been resolved as a result of all these clinical studies now that have been conducted.
Welcome to the Proof Podcast, a space for science-based conversation exploring the health and longevity benefits that come with mastering nutrition, physical exercise, mindfulness, recovery, sleep, and alignment. Facts, nuance, and trustworthy recommendations, minus the hyperbole. Today's episode is with Mark Messina, PhD. Mark is an internationally recognized expert on the health effects of soy foods and soy isoflavones, or phytoestrogens, as they're often called. What is the history of soy consumption? Why is soy so controversial? Is soy safe for infants and young girls? Does soy affect a woman's risk of developing breast cancer? How does soy affect male hormone levels? The role of our microbiome in metabolizing soy isoflavones, the isoflavone content of different soy foods, soy allergies, organic versus non-organic soy. We cover all of this and more. A conversation that I think you'll find interesting regardless of whether you currently eat soy foods or not. With that, please enjoy my conversation with Mark Messina, PhD. Let's start here with a bit of history. I thought that could be a good idea. How far back in time does soy consumption go? Do we have a sense for when humans first started eating soy foods?
You know, there's a lot of debate on the topic. Some recent archaeological evidence actually suggests that people were consuming soybeans as much as 7,000 years ago. But aside from the archaeological evidence, I think if you look at some of the data from Bill Shurtleff's Soy Food Information Center, and Bill is absolutely the world's leading expert on this topic, I think you go through the written records, and you're talking probably a couple of thousand years.
And at what point did soy become such a controversial figure in the discussion of diet, and why is it so controversial, so polarizing?
Yeah, well, that's a lot more recent than a couple of thousand years ago. From my perspective, soy started to become more mainstream in non-Asian countries back in the late 1960s and early 1970s with the sort of the counterculture revolution, the hippie movement. A lot of people started to become vegetarian and began eating tofu. In 1975, Bill Shurtleff, who I just mentioned, actually published two groundbreaking books, one the Book of Tofu and then also the Book of Miso. So he actually had a lot to do with bringing tofu and soy in general to a non-Asian population. I don't think it really caught on until the early 1990s when research began to surface suggesting that soy may have some rather impressive health benefits. So it was long recognized that soybeans and soy foods are good sources of protein, low in saturated fat. So many people gravitated towards soy foods for those two reasons alone. But in the early 1990s, there was a lot of attention on the benefits or the health effects that foods may have above and beyond their nutrient content. And so there was a lot of talk about functional foods and phytochemicals and designer foods. And I think soy was at the forefront of that attention. And in 1990, the National Cancer Institute in the U.S. funded about $3 million worth of research looking at the potential role that soy may have in reducing risk of cancer. And $3 million back in 1990 was quite a bit of money. And when that money was made available and the NCI sort of gave its blessing to soy, it brought attention not only to the role that soy may have in cancer prevention, but also a number of other areas. And the focus was largely on the isoflavones or plant estrogens in soy. And that's really what makes soybeans and soy foods unique. soybeans are higher in protein than other beans, and they're much higher in fat. Almost 50% of the calories in soybeans comes from fat, whereas most beans are almost fat-free. So those two macronutrient elements really distinguish soy, but more to a much greater extent, it's because soybeans are a uniquely rich source of these isoflavones. So if you consume a diet that is high in soy, your diet's going to be quite high in isoflavones. If you don't consume soy, it's almost devoid of isoflavones. So the isoflavones were responsible for much of the focus on the potential health benefits in the early 1990s and continues today. But the isoflavones also became somewhat controversial, and concerns were raised about the isoflavones perhaps increasing or worsening the prognosis of breast cancer patients, affecting growth and development, all sorts of things. So that's where we have the controversy.
Yeah. There's a bunch of stuff in there that I want to unpack, those that you just mentioned, and thyroid health, and all things that you're super familiar with, that we'll come back to. So I'll put a pin in a few of those things. Today, you're the Director of Nutrition Science and Research at the Soy Institute, I believe. What can you tell us about the Institute, when it was established, and sort of what its mission is and what your role is there?
Yeah, thanks for the question. The Soy Nutrition Institute Global was founded in 2004. And its support comes from the United Soybean Board, which represents almost 600,000 U.S. soybean farmers. And then there are individual companies that pay membership dues. So you have large ones like Archer Daniels Midland, and then much smaller companies that maybe are making tofu, and then more startup companies like Impossible Foods, which of course makes the Impossible Burger, and another other soy-based meats. So the mission of the organization is really to educate health professionals about the health effects of soy foods, soybean components, and soybean oil. So we really try to focus our outreach education on health professionals, physicians, and also dietitians. I think that's the biggest group. So we do that by, publishing papers, and I've involved with that to a great extent, and then taking that peer-reviewed information and communicating it to dietitians who have nutrition expertise, but not necessarily expertise in the soy area.
Yeah, you've certainly published some of the best reviews on soy that I've read. So I will make sure that those and your Google Scholar link, etc., are all in the show notes for people to take a look at. I think there's this common view out there, and I'm interested to see if you feel the same way, that when industry is working with researchers like you, that because of that conflict, the results of the studies cannot be trusted. And I think that's just a view that people just flat out hold, that if the industry is connected to the research in any way, it's only going to focus on the positives and not really any of the potential negatives. And in the case of soy, when I kind of sit back and just look at different views that are out there and listen to people that don't consume soy or have concerns, it seems that a lot of people take this precautionary approach, and they think, when there's smoke, there's fire. Is that something that you've kind of observed or felt?
Well, first of all, you make a good point about, and I've been facing that issue very recently with a letter I wrote in response to an article that cited a paper that I was a co-author on, and noted that we were affiliated, some of us were affiliated with the soy industry. And, this was a professional paper in a peer-reviewed journal, and I think the author should be able to actually look at the credibility of the science, the validity of the information, rather than just focusing on what our affiliation might be. The other thing is that in most of the papers that I personally have co-authored, there's a whole bunch of co-authors on those papers who have no identification with no affiliation with the soy industry. So a good case in point is a paper that was published a couple of years ago. It was 30,000 words, 700 references. And there were 10 authors. 7 had absolutely no connection to the soy industry. And 2 had a very minor connection. They received some honorarium in the past. And then I have, of course, a major conflict of interest. And I know one nutrition professional who completely dismissed the 30,000 words because 2 authors had 2 out of the 10 had a minor connection, and 1, myself, had a large one. All we can do is do good science and publish in the best journals. And in the past, the industry has, and I don't speak for the industry in any form or fashion, but I know industry has been criticized for not supporting research when they were making claims about their products. So you sort of can't have it both ways. It's very difficult for researchers to get governmental funding because there's only so much money available. So I think industry should be doing research to find out more about their product. But I completely agree with you that there is this concern that industry of an industry bias. But let me just make one other point real quickly, is that almost without exception, the safety concerns that were raised about soy were based, and still today are based, on in vitro and animal studies. And for obvious reasons, it's very easy to do animal studies. They're relatively inexpensive and they don't take long to conduct. So the animal studies often will be published before the clinical research or the observational research is published. So if you go one by one through the various concerns that have been raised, whether it be, thyroid function, concerns about breast cancer, those concerns were based entirely or almost entirely on rodent studies. But then you have, for example, a meta-analysis published a couple of years ago that included 18 clinical studies, found no effects of soy on the 2 main thyroid hormones. And now you have, for example, and the American Cancer Society, just in their most recent paper, 2022, saying that soy may reduce the risk of breast cancer recurrence. So it actually may benefit women with breast cancer. And the World Cancer Research Fund, just a couple of weeks ago, identifies soy as one of 5 factors that may reduce recurrence and improve survival from breast cancer. So, personally, what I try to do is in my presentations is to cite these independent groups, like, for example, the Food and Drug Administration in the U.S. conducted a complete safety review of soy. In addition to extensively looking at the scientific literature, they considered more than 1,300 comments submitted by the public. And the FDA rejected all of the safety concerns. The only one they, of course, acknowledge is that in some individuals, soy protein can cause an allergic reaction. So I think a lot, and same thing with male feminization. So there was a case report describing a single individual, male, 60 years old, who developed feminizing effects, probably as a result of his soy consumption, but he was consuming 3 liters of soy milk per day, an absolutely insane amount of soy to consume. He was consuming almost 10 times more of these isoflavones or phytoestrogens than is typical in Japan. So that kind of single individual was actually responsible for a lot of the concerns raised about male feminization. But 2 years ago, there was a meta-analysis, 41 clinical studies, no effects of soy on testosterone levels or estrogen levels. So I'm very convinced that soy is safe, and I think the human data and the observational data would back me up.
So just to double click on that last point, it sounds like this is another scenario where the dose is very important. So we'll get into isoflavones, but what I'm hearing from you is that they can be beneficial at a certain dose, but then sure, like many things in life, if you overconsume them, there could be deleterious effects. Would that be correct to say?
That's certainly true, but I do want to emphasize that I don't recommend more than 4 servings of soy per day, because no matter how healthful any given food is, you don't want to place too much emphasis. Soy is a fantastic bean or legume, but there are a lot of very interesting pulses and beans that should be part of your diet. It's in fact, that if that individual who consumed the 3 liters of soy milk had consumed 3 liters of cow's milk, he would have exceeded the safe upper limit for calcium intake. So in my opinion, those kind of extreme examples really are not informative at all. And when you actually look at the data and you see intervention studies that provide amounts of isoflavones found in 6 and even 8 servings of soy, you still don't even see any adverse effects. So again, the adverse effects are seen in animal studies. Rodents metabolize these plant estrogens very differently than humans do. So again, they're not a good model for providing insight about soy. They are part of the scientific literature, but in the end, you need to rely on the human data.
So men that are concerned or interested in understanding more about soy, they can be rest assured that soy consumption within the ballpark of up to 4 serves a day, which you just mentioned there, is not going to affect erections or penis size or gynecomastia, I guess colloquially known as man boobs, things like that.
Yeah, absolutely. So with gynecomastia, moobs, there was a 3-year study provided the equivalent of about 4 servings of isoflavones or amount of isoflavones from 4 servings of soy, 3 years. No evidence at all of breast swelling, any gynecomastia. 3 clinical trials have looked at intervention studies have looked at the effects of soy or isoflavones in sperm or semen. No adverse effects. And again, I mentioned the meta-analysis, 41 clinical studies, no effects on testosterone, estrogen levels. And there was a meta-analysis, again, of 9 clinical studies showing soy promotes growth or enhances gains in muscle mass and strength in response to resistance exercise training to the same extent that animal protein and whey protein does. Whey has generally been considered to be the optimal protein for building muscle, and we saw in the meta-analysis that soy was as good as whey. And I think the consensus now is that it's really the amount of protein that you consume for the most part, not so much the type of protein you consume.
Yeah, I would certainly agree with that. I think that's something that even people who have historically been very pro animal protein have begun to change their mind on or change their views on as more data's come out.
And I think I know who you're referring to there, but yeah, sometimes he was affectionately called Dr. Whey. And yeah, I really respect him for that because he's a wonderful scientist and he's a great communicator, and he goes with the data.
So the controversy that exists, it seems like, firstly, a lot of this stems or comes back to these bioactive compounds in soy foods called isoflavones. Another word used to describe them is phytoestrogens. These are polyphenol compounds, but based on what you're saying, is it, groups like Western A Price, for example, which are notorious for scaring people from soy, are they the ones that are placing too much stock in animal data and are not considering the human health outcome? Is that where what's leading to their different views to the guidelines and to what your views are?
Yeah, but I don't think they are say much about soy anymore. They were very active between say mid 1990s to 2005. And in fact, this is a true story where I was reading something in April 1st, April Fool's Day. And someone handed me something that Western A Price Foundation had written about soy. And I literally thought it was a joke because I thought it was so scientifically inaccurate. And, everything they wrote was extremely hyperbolic. I do want to recognize, though, that as I was saying before, initially you have animal studies and you get some very strange results with, they say humans are not little rats. And not big rats. And so, you can't dismiss the animal studies. What you need to do is then they're good for hypothesis generation, just like observational studies are. And then hopefully you can do a clinical trial to address a potential benefit or a potential concern. So soy is a heavily researched food. So there's literally hundreds and hundreds of clinical studies and observation studies that you can now rely upon in systematic reviews and meta-analysis of those data.
Mm-hmm.
So it takes a while. So if you look at the case of breast cancer, so in the late 1990s, one laboratory in University of Illinois here in the States found that if you implant breast cancer cells, human breast cancer cells into mice, and you remove their ovaries and their immune system, and then you give them isoflavones, it stimulates the growth of those tumors, existing estrogen-sensitive tumors. So, we didn't have human data to refute that at the time. And that lab produced study after study after study for the next 10, 15 years, tweaking the model a little bit. So the consensus was, based on the animal data, that soy may worsen the prognosis of breast cancer patients. But now we have 13 clinical studies that show soy does not increase or affect breast tissue density, which is a marker of breast cancer risk, and 6 clinical studies that actually did biopsies of the breast before and after exposure to isoflavones or soy, no adverse effects whatsoever. And then you have the observational studies suggesting women who consume soy after a diagnosis of breast cancer actually benefit from doing so. And in fact, a study literally was published today, from Korea, which showed the consumption of fermented soy reduced recurrence of breast cancer. So I don't have a problem with people relying on animal studies when there are no human studies upon which to make a conclusion. I do have a problem when people don't take the time to highlight the fact that animal studies are often not good predictors of effects in humans. So I see, even in the scientific literature, people making very definitive statements in a peer-reviewed, article, and then you go look at the reference and it's an animal study.
Mm-hmm. Right. The recurrence of breast cancer and the risk reduction that you just mentioned there in that latest paper, is that dependent on the type of breast cancer?
It actually shows, it varies. So we see, in some papers, you see better effects in women who have had estrogen sensitive tumors, estrogen receptor positive, but in other studies you see just as good of effects in ER negative tumors that don't respond to estrogen. And it's not clear what the mechanism is. There's been a lot of discussion over the years that these isoflavones or phytoestrogens may act like anti-estrogens, but it's very difficult to point to any clear anti-estrogenic effect in clinical studies. And in fact, this may come as a bit of a surprise, and it's a paper that I'm working on now. When you look at 3 markers or sort of health outcomes that are affected by the hormone estrogen in postmenopausal women, like the vaginal maturation index, or endometrial thickness, or follicle stimulating hormone, those outcomes are affected by the hormone estrogen, and they're not affected by soy or isoflavones. So again, a lot of our understanding is based on animal studies, and you often don't see those results replicated in humans.
Let's zoom in a little bit on the soy isoflavones themselves, or phytoestrogens. So what are they, and how are they different to estrogen?
Yeah, so they're diphenolic compounds, and they really have a very, very wide distribution in nature. So tiny, negligible amounts are found in fruits and vegetables and beans. But the only commonly consumed food, red clover as well, it's not a food, of course, but they're the only commonly consumed food that contains what I consider to be physiologically relevant amounts is soybean and soy foods. So in Japan, for example, typical isoflavone intake among older men and women is about 30 to 40 milligrams per day. In the U.S., isoflavone intake is fewer than 3 milligrams per day. So as I said at the beginning, if you consume soy, your diet's pretty high in isoflavones. If you don't, it's almost devoid of isoflavones. So these isoflavones, in some ways have a chemical structure similar to the hormone estrogen. So they bind to estrogen receptors. And for a long time, we only recognized the existence of one estrogen receptor, now called estrogen receptor alpha. And so isoflavones were considered to be relatively weak estrogens based on binding to that original estrogen receptor. 1996, it was determined or discovered that there was a second estrogen receptor. Isoflavones have more affinity for that second receptor, estrogen receptor beta, and that's potentially important. So estrogen binds with equal affinity to both estrogen receptors. Isoflavones like estrogen receptor beta a lot more than estrogen receptor alpha. And when you activate estrogen receptor beta, it tends to have an anti-proliferative effect. When you bind to estrogen receptor alpha, it has more of a proliferative effect. So it's often thought that binding to estrogen receptor beta can actually inhibit the effects of compounds that bind to estrogen receptor alpha. So it's a little bit of a complicated topic, but so at the molecular level, you see that isoflavones can be differentiated from estrogen because of the way their preference for binding to each of these two receptors. But to be honest, when I make conclusions about the actions of isoflavones, I always just rely on the clinical data because I mentioned in 1996 we identified or discovered another estrogen receptor. 20 years from now or tomorrow we may find that there's a third estrogen receptor somewhere, and there sort of actually is already. And so our understanding of what happens at the molecular levels of isoflavones may vary a lot. So what you want to rely on is a clinical finding. So do isoflavones increase breast cell proliferation, in women? So if you take a biopsy before and after exposure to soy isoflavones, does cell proliferation increase? It doesn't, whereas if you give combined hormone therapy, estrogen plus progesterone, within just 10 weeks, you can get, a tenfold increase in cell proliferation. So I like to rely almost exclusively on the clinical data for when I'm forming opinions about the effects of soy foods.
How are these phytoestrogens in soy different to, say, the phytoestrogens, lignans in flax seeds, for example? They often come up in this conversation as well.
Yeah, their structures are very different. But again, I don't think that the lignans are nearly as potent as the isoflavones are in soy. I tend not. I really focus entirely on isoflavones in soy, and it drives me crazy a little bit when people speak outside their area of expertise. So I'll leave it at that. But let me make one other point about when people sometimes refer to isoflavones as sort of weak estrogens. First, I think that's a mischaracterization. But second, if they're that weak, then it's difficult to suggest that they may have benefits, right? I mean, you have to have a certain potency in order to have a benefit, exert a benefit, just like you have to have a certain potency if you think you might cause a harmful effect. The other point is that while they have, in some sense, they bind to the estrogen receptor less well. So what's referred to as a relative binding affinity is lower than it is for estrogen. But if you're consuming soy foods, the concentration of isoflavones in your blood is 1,000-fold higher than it is of the hormone estrogen. So even though you could refer to them as weaker, because the concentration is so high, you can certainly propose that they're going to have a physiological effect.
Do they increase levels of estrogen in the body?
Absolutely not. I mean,
Okay.
that was shown in a meta-analysis by Hooper and colleagues published in 2009. And I've been looking at some of the data since then, and it's very consistent. There's no effect on estrogen levels. That doesn't mean isoflavones can't exert an estrogen effect independent of, the hormone estrogen, but they actually don't raise estrogen levels.
There's, I guess, this general idea out there that something that exerts an estrogenic effect is automatically negative. Do you think there is an oversimplification of estrogen and its role in the body?
Well, of course, because estrogen may be, first of all, men make estrogen just like women do, and older men actually make more estrogen than older women do. Something that's often not recognized, which is why when you're looking at the effects of soy in men, you want to look at both testosterone and estrogen levels. But estrogen has a lot of benefits that may be important for, cognitive function. Hormone therapy is probably reduces risk of fractures, increases bone mineral density. Obviously, taking estrogen alleviates hot flashes in menopausal women. So, it has benefits and is potentially harmful for example, estrogen increases risk of endometrial cancer. And that's why if a woman has a uterus, you have to take progesterone with it because it'll inhibit the effects of estrogen. Yeah. So you have to look at each individual outcome in relation to soy or isoflavones. So, I'm not, for example, there's some data suggest that isoflavones improve memory, alleviate hot flashes, but the trials that have looked at the effects of isoflavones on bone mineral density have been very disappointing. So there were a lot of short-term studies showing an effect on markers of bone turnover or markers of absorption and formation. So very encouraging. I was very excited about the potential for soy to reduce risk of fractures. And there are a couple observational studies that suggest that's the case. But then 4 large clinical trials, 2 to 3 years in duration, did not show benefits of isoflavones.
And I think you already emphasized this, but I had a previous conversation on menopause with an endocrinologist, and we were talking about when hormone therapy may be contraindicated, and a history of breast cancer came up as one of these situations where estrogen therapy may be contraindicated. But from what I'm hearing from you, soy isoflavones are not having the same effect on breast tissue, so it's the same concern is not there for someone who has a history of breast cancer?
So obviously it's a very important, sensitive question. And as is often the case, there aren't definitive data, but the evidence that does exist is very supportive of safety. So as I mentioned, soy does not, or neither do isoflavones, adversely affect breast tissue. And that's the conclusion of the European Food Safety Authority from 2015 and the German Research Foundation in 2018. So they looked at this issue in postmenopausal women because that would be the group that would be most concerned, because the thinking was that with their lower estrogen levels, if you take isoflavones, then the isoflavones are going to have like an estrogen-like effect. So they do not adversely affect breast tissue based on the breast tissue density or breast cell proliferation. And then the observational studies, and again, these are not clinical intervention studies, they're observational studies, and there are 5 of them now, show that consuming soy after a diagnosis of breast cancer is beneficial. It's an association, but we're sort of 5 for 5. So it's impressive. And at least 10 scientific organizations, from the Irish Society of Oncology to the Canadian Cancer Society, American Cancer Society, at least 10 organizations have concluded that soy is safe for breast cancer patients. Now, it would be wonderful to actually conduct a clinical trial where you take breast cancer patients and half of them consume soy and the other half consume a control protein, could be some sort of animal protein, and then look at recurrence and mortality over maybe a 5 or 6 year period. That would definitively address the question you raised, but that study has not been conducted. And, before I forget, I do want to remind people that, soy is a food. When you eat tofu, you're just not you're getting isoflavones, but you're getting a heck of a lot more. So it's a wonderful source of protein. It's a really high quality protein, regardless of whether you measure it using the protein digestibility corrected amino acid score, the newer method, DIAS. And soy has omega-3 fatty acids, full fat soy foods and soybeans. Foods like tofu has linoleic acid in it. It's got some decent amount of B vitamins. So I like, we want to think of it not just as a source of isoflavones, even though that's where a lot of the attention is, but as a source of good nutrition. And you may know that in 1999, the U.S. Food and Drug Administration approved a health claim for soy foods and coronary heart disease based on the cholesterol-lowering effect of soy protein. So that's a direct effect of the protein, not because soy foods are high in polyunsaturated fat and low in saturated fat. So it's a direct effect of the protein. It's a modest effect. It's a 3 or 4% reduction, but I think that's relevant at both the clinical and the population level.
On that, what's the history of that? Because my understanding was that later on that was then revoked, and it was no longer allowed to. That claim was no longer allowed to be on packaging.
That's not correct, but I understand why you said it, because so the claim was approved in 1999. And then in 2007, just to ruin my Christmas, because it was announced in December of 2007, the FDA announced that they were going to reevaluate the evidence in support of the health claim. So the claim was approved in 1999, 2007. They said that they were going to reevaluate the data. In 2017, so literally like a decade later, they intimated that they were going to revoke the health claim because the data were inconsistent. So that was 2017. A number of meta-analyses have been published. David Jenkins did one at the University of Toronto. He actually took the 46 studies that the FDA considered for their analysis and showed a statistically significant reduction in LDL cholesterol. And basically every 6 months to a year since 2017, the FDA has delayed their decision about the health claim. So as of now, you can definitely still say that soy protein lowers cholesterol levels. We don't know what they're going to end up concluding. It may be that they go from the current claim to a little bit of a weaker claim, what's referred to in the States as a qualified claim. And so you would still be able to make a statement on a package, but the nutrition studies are notorious for being inconsistent because many nutrition studies are very small in size, short in duration, and people are different. So, age could be a factor, gender, the background diet could be an issue. So there is a lot of variability in the data. But remember also, of course, if you're actually consuming a soy food like tofu in place of a source of animal protein that's higher in saturated fat, you get a benefit because of the change in the fatty acid content of your diet. And then I think you also get a boost from the protein itself. So I think there's a double benefit there.
Right. Some of the benefits coming from what you're removing from your diet, reduced exposure of certain things.
Yeah, not for the health claim, but in general, that would certainly be the case. Yeah. And in fact, study after study shows, if you look at something like replacing saturated fat in the diet, what you replace the saturated fat with in terms of either, whole carbohydrate, refined carbohydrate, monounsaturated, or polyunsaturated, that's going to determine the extent to which your risk is reduced. So if you actually lower your saturated fat intake, but by consuming more refined carbohydrates, your risk actually increases a little bit. It doesn't decrease. But if you replace it with polyunsaturated fat and monounsaturated fat, your risk is going to decrease.
Yeah, that's a very important principle. The replacement nutrient matters a lot, and that trips a lot of people up because you can find a study that shows that saturated fat is not increasing risk of cardiovascular disease, but you really need to be careful and look at, well, if people were not eating saturated fat, where were their calories coming from instead?
If you eat something else, you have to eliminate something from the diet in order to keep your caloric intake, constant. I do think, though, that we have a much more nuanced understanding of the impact of saturated fat on risk of heart disease. I really can't comment in detail because it's outside my area of expertise, but very clearly the food matrix may affect how saturated fat actually affects risk of heart disease.
Yeah, I had a previous episode with Dr. Jill Carvalho that people can go back to, and if they want to explore that in detail. Thank you for correcting. I stand corrected with regards to the health claim being revoked. Quick one. If you'd like some inspiration to take your fermented food game and gut health to the next level, be sure to check out my digital plant-based ferments guide. Inside are some of my favorite recipes, including my soy labneh and homemade kombucha. Learn more at theproof.com/ferments. That's theproof.com/ferments. It must drive you insane when you see oversimplification on social media. Often what I'll see is, a graphic that's been created and, something along the lines of soy endocrine disruptor. Is that another clear mischaracterization?
Absolutely. And it does drive me. I think I'm getting used to it over the years to seeing all this misinformation. And there's actually less misinformation than there was 5 and 10 years ago because all these human studies have been published. So most of the time now when you see blog posts or, any kind of article sort of for the general consumer on, for example, soy and breast cancer, I think most of the articles now highlight the fact that although we used to think soy might be harmful to breast cancer patients or high-risk women, that's no longer the case. Yeah, for the endocrine disruption thing, I referred to a paper before that was 30,000 words and 700 references, and that was the focus of the paper. And we concluded, the 10 authors, that neither soy nor isoflavones warrant classification as endocrine disruptors. All that information is based on the notion that soy is an endocrine disruptor is based on animal studies. And what's interesting about that is when you look at most endocrine disruptors, these are pretty scary chemicals found it could be in the environment, could be in something in plastic like bisphenol A. You can't really do intervention studies using those compounds because it would be unethical. In contrast, in the case of soy and isoflavones, there's literally hundreds of clinical studies that can address whether these isoflavones in soy are having any adverse effects. So we really have just a wealth of data, not only the observational data from countries like Japan and China and Korea, but we have intervention studies in non-Asian populations that look at all sorts of adverse effects, and they're just not seen. And in fact, even when the primary outcome is not like an adverse effect, like an effect on testosterone or something, if you're doing a clinical trial, you always report adverse events, and you're not seeing an effect of soy versus the control diet.
Talk to me about the kind of metabolism and absorption of soy isoflavones. So my understanding is that for many polyphenols, a very small percentage are absorbed in the small intestine, and the large majority find their way into the large intestine, and then the bacteria get to work. I guess you could consider them prebiotics potentially. What's the story here with soy isoflavones?
Yeah, it's a good question. And I think that soy might be a prebiotic, but because of the oligosaccharides in soy, these small sugars that aren't very well digested, so they do make it down to the colon. And in fact, back in, I think it was about 1990, Japanese researchers suggested replacing the oligosaccharides in soy replacing table sugar with the oligosaccharides in soy because they were sweet, and they'd have this prebiotic effect. So, but you're right. Isoflavones are not well absorbed like most, phenolic compounds. So many of them do make their way down to the colon, and to some extent they can be reabsorbed or absorbed from the colon. But I think one of the most interesting aspects of this metabolism is that in about 25% of Westerners, they host the intestinal bacteria that converts one of the isoflavones in soybeans called daidzein into an isoflavonoid, similar to an isoflavone, called equol. And back in 2002, a hypothesis was proposed by Ken Setchell, one of the absolute pioneers in the isoflavone field, really brilliant guy. He proposed that people that host that bacteria that can convert daidzein in soybeans into equol are more likely to benefit from a soy consumption. That's a very interesting hypothesis. It still remains a hypothesis, and the kind of clinical studies that need to be done to definitively prove or disprove that hypothesis have not yet been conducted. But that's one of the more interesting aspects of isoflavone metabolism. It's also worth noting, like is true for lots of compounds, that there's a lot of bio-individuality when it comes to metabolism. So, if you give 50 people in a room 50 milligrams of isoflavones to consume, their blood levels are going to be very, very different despite consuming the same amount of isoflavones. And when you consume fermented soy foods such as miso, natto, and tempeh, the isoflavones to varying degrees are in a slightly different form. So in nature, in soybeans, isoflavones are connected to a sugar, so they're called glycosides. As a result of fermentation, more of the glycosides with the sugar attached are converted to aglycones without the sugar. And those aglycones are absorbed more quickly. And so you can get higher blood levels for at least a short period of time than you would in response to the consumption of isoflavones when they're in the form of unfermented soy foods. It's not clear that that's an advantage or a disadvantage, but it's clearly one difference. And that reminds me, and it's an important point. For a long time, you saw online a statement that, first of all, that Asians ate very little soy. They would talk about a tablespoon of soy a day, literally. And the reason that started, that's classic misinformation, not even fake news. It's a misunderstanding, because what they were looking at was 9 grams of soy protein per day, which could be a cup of soy milk or, 100 grams of tofu. And they were looking at 9 grams, and they thought a tablespoon of a liquid weighs about 14 grams. So they thought that 9 grams of protein meant that Asians consumed a tablespoon of tofu a day. Amazing, because that was so wrong and easily to point out. And it persisted for years. The other misconception was that Asians eat mostly fermented soy. And the opposite is true, because ethnic Chinese don't consume much in the way of fermented soy, excluding soy sauce, which is, of course, a condiment, not a food. So if you look in China, probably not more than 95% of the soy consumed is in unfermented form, mostly soy milk and tofu. In Korea, it's about 70% unfermented. And in Japan, it's about 50-50. So they eat tofu and then miso and natto. So most of the soy consumed around the world is actually consumed in unfermented form.
So 25% of the population in Western populations will have the bacteria in their colon, in their large intestine, that will metabolize daidzein and convert that into equol. So am I right that the other 75%, they'll still metabolize daidzein, but it will just end up in producing a different compound?
That's right. It's for short. It's called ODMA. Yeah. So you'll metabolize daidzein to both. If you're an equol producer, you'll metabolize it to both compounds. If you're not an equol producer, just the one compound, ODMA. And again, we don't know if that's an advantage or not. It's the hypothesis that's literally been around for 21 years now. It'd be nice to get some more definitive data but we just don't have it. It'd be fairly easy to design an experiment to answer the question, but it just hasn't been done yet.
Yeah, what would that experiment look like?
Well, I think the easiest way is actually just to give equol to someone to look at the benefits versus maybe just in non-producers of equol, and then the other group could have just isoflavones, so they wouldn't produce equol from the isoflavones, but they would be exposed to equol. There's a lot of ways that you could do it. And then it would be a question of what outcome you would look at. And that's a little bit more tricky. You could, would you look at bone? Would you look at hot flash alleviation? Would you look at arterial health? So that's a little bit more tricky to figure out what outcome would be best studied.
Can you measure equol in the blood and potentially in an observational study look at cancer recurrence and equol concentrations?
Done all the time. But that's the problem, is that these are associations. So you don't know if it's the equol per se that's having that is the reason for the outcome, or if it's because people who host that bacteria are different in other ways from people that don't host the bacteria. So there are quite a few intriguing observational studies that support the benefits of equol. And bear in mind, it's not one or the other. I mean, genistein is the predominant isoflavone in soybeans, and that's been studied very extensively, more than any other isoflavone. And genistein, we know by just studies that administer genistein directly, that genistein has benefits. So it's not one or the other.
So it's sort of a watch this space. It's a bit too early to be thinking about how we can modify our diet to have more bacteria that produce equol, or taking probiotics, things like that.
Yeah. And as obviously the microbiome is a really hot topic. And science sometimes goes in, it's almost like fashion. Everybody gets an idea about homocysteine and heart disease, or vitamin E is the big, and I think right now, and for a long time now, at least 10 years, the microbiome and microbiota have been really, really hot topics. So that's a subject that I'm not well versed on, but it's very complicated, but there's just a zillion papers on it. The other issue that soy faces, and I don't know if you had anyone talk about this before, but it's the whole concept of ultra-processed foods. And that's become very big with the NOVA food classification system. And that directly relates to the soy industry and soy foods, because 90% of the plant milks, including most of the soy milks, are actually classified as ultra-processed foods. And all of these, sort of the new generation of soy burgers and plant burgers, whether it's, Beyond Burger made with pea protein or the Impossible Burger made with soy, they're also classified as ultra-processed food. And according to, the NOVA food classification system, which was created in 2009 by Brazilian researchers, these are foods that you should avoid as much as possible. And so it's put a lot of a focus on whether these foods should be part of a overall healthful diet, whether you should stick to tofu as opposed to eating a soy burger. I'm very convinced. I love soy burgers and I drink a lot of soy milk. So my opinion is that although they're classified as ultra-processed foods, a soy burger is a heck of a lot different from a Twinkie or, some corn chip, which are also classified as ultra-processed foods. So I don't think that system is sufficiently nuanced to group all these foods, in a similar way.
If we're thinking about the bioactive soy isoflavones, though, potentially having some benefit, I'm of the understanding that as you process soy, usually that means that the soy isoflavone content actually goes down, which is the opposite, I think, of what some people think. They sort of think of a soy protein isolate or perhaps a TVP as a very concentrated source of soy isoflavones. So perhaps you can talk to the amount of soy isoflavones in different sort of common soy foods.
Yeah, that's a great question, and you're right. I think people often get it 180 degrees wrong. So in a traditional soy food, like tofu, soybeans, edamame, there are approximately 3 to 4 milligrams of isoflavones per gram of protein. So if you think of a cup of soy milk as having, let's say, 7 grams of protein, 8 grams of protein, then you can estimate isoflavone content pretty well. So it'd be 7 or 8 times 3.5, about 25 milligrams. So I like to think of a serving of soy as providing about 25 milligrams of isoflavones. I mentioned before that in Japan, typical isoflavone intake among older men and women is about 40 milligrams per day. So that'd be about 1.5 servings per day on average. Now, of course, you have at the higher end of the spectrum, you have people consuming 2 and 3 servings a day, but the average is about 1.5. So it's about 3 to 4 milligrams of isoflavones per gram of protein. Whereas in these more concentrated sources of protein, such as soy protein isolate and soy protein concentrate, by definition, they're 90% protein and 65% protein. So you take the bean. In the case of the isolate, you take the bean, you get rid of the fiber, for the most part, the carbohydrate, and the fat. You're left mostly with the protein. With the concentrate, it's about 65% protein. So those products, when they're made in the typical way, end up having about maybe 10 to 20% of the isoflavone content that you would find in a traditional soy food when expressed on a milligram per gram protein basis. So if you're consuming 8 grams of soy protein isolate, in most instances, you may only be getting anywhere from 2 to maybe wouldn't even be 8 in most instances, but let's say 2 to 8 milligrams of isoflavones. If you're consuming 8 grams of soy protein isolate, if you're consuming 8 grams of protein from soy milk, you're getting about 25. So and what you often see, and you referenced this or alluded to it, is you often see people saying when they're writing about the concerns about isoflavones, they'll say, well, consuming soy foods is okay, but stay away from the concentrated sources like soy protein, concentrated and soy protein isolate. And those are the ones that are actually low in isoflavones. So the Impossible Burger has 2 milligrams of isoflavones, which is nothing. I mean, there's 25 milligrams in a cup of soy milk. So if for whatever reason you were concerned about isoflavones, and again, I don't think there's any reason to be. The Human Day are very supportive of safety. The FDA reached that conclusion. The European Food Safety Authority reached that conclusion. But if you are concerned about isoflavones, what you would actually want to eat are these products made with these concentrated sources of protein. So I look at those foods primarily as sources of protein. Now, many of the clinical studies, in fact, almost all of them, actually have used the soy protein isolate and concentrate because in a Western population, if you're doing a 6-month study, it's difficult to ask someone to consume 2 servings of tofu per day who is not used to eating that type of food. Whereas with the soy protein isolate, you can put it in a beverage, add it to orange juice or any other beverage. You can actually use it to bake with, and then you can take a protein like whey or casein as a control protein. So the participants won't know which food they're consuming. If you're eating tofu, you're almost certainly not going to be blinded. You're going to know you're eating tofu. So most of the clinical work has been done with the concentrated sources of soy protein, and those are the products that have shown a reduction in LDL cholesterol levels. So, if you're looking for isoflavones, you go to traditional soy foods. If you're only concerned about protein, you can eat the traditional foods or the foods like the Impossible Burger.
Where does TVP fall?
That actually that's soy flour, and that would be rich in isoflavones because if you're looking at TVP made from soy flour, which is 50% protein, that's really just a defatted product, and that would be a product that would have a lot of isoflavones.
Just remind folks, so what would you say is the safe upper limit of soy isoflavone intake per day?
Yeah, I'm glad you asked me that. So in free living populations in let's say Shanghai is a really high soy consuming region within China. Uh, I think a lot of people would be surprised to learn that not all regions in China actually consumes much soy. I mean, some consume almost no soy. It's very heterogeneous in terms of their dietary pattern. But Shanghai is obviously an urban area, very high soy consuming population. They're consuming about 40 milligrams, 35 to 40 milligrams on average, but there is a segment of the population, like 10% of the population, that's consuming about 100 milligrams of isoflavones per day, which is about 4 servings of traditional soy foods. So my basis for the limiting isoflavone upper limit is 100 milligrams per day for 2 reasons. One, there's no historical precedent for consuming more than that, based from Japanese population or Chinese population. Second, if you're getting 100 milligrams of isoflavones from soy foods, it means you're consuming at least 4 servings per day. And you don't want to consume more than 4 servings of anything. No one would say you should consume more than 4 servings of broccoli or kale. Everybody loves kale. It's a great healthful food. But you don't, you want to consume some kale, a variety of different vegetables. So my upper limit is not based on safety concerns. It's based on the dietetic principles of, variation and moderation. And when you look at the clinical studies, some of them like there was a bone study from Taiwan, 300 milligrams of isoflavones for 2 years, no adverse effects. So you have data to show that isoflavone exposure beyond 100 milligrams is perfectly safe. But when you're thinking about a food, again, variety and moderation.
Right. Okay. So 100 milligrams a day as a kind of general principle. I might put a table into the show notes then that shows for the different types of soy foods on a per serve basis the approximate amount of soy isoflavones, and then people can get a feel for what that might look like a day on their plate kind of thing. I do think that there probably are some listeners, and I'm thinking mostly here of males who are doing a lot of strength training and working out, who are exceeding that by some amount. A fair amount in some cases could be up at 200 milligrams or 300 milligrams. As you say, there is some data to suggest that is not going to be an issue. But if someone is listening and thinking, gosh, Mark, I'm having much more than that in order to reach whatever protein target they're striving for their sort of performance goals or whatever, is there any tests, blood tests or things that you would recommend they could go and look at if they wanted to be sure that it wasn't having a deleterious effect on their health?
No, not really. I mean, because I really would have no idea. I mean, if you could look at testosterone levels, but again, in the clinical studies, there's no effect. But I would push back on just something you said, which is that, if you think of a weightlifter, like I take a lot of protein because I'm an older individual and I do weightlift. I'm trying to, keep as much muscle mass as I can. So I eat a pretty high protein diet, and certainly in the days that I'm weightlifting, it's really high. But if you're consuming soy protein, which is what a lot of these folks might be doing to get their protein boost, it's going to be in the form of soy protein isolate, which is really going to be low in isoflavone. So if they're consuming 50, even if they're consuming 50 grams of soy protein per day, they're from the isolate, they're not going to be getting, an excessive amount of isoflavones at all. And presumably they're getting 50 grams, if they're trying to, with the typical recommendation, 1.6 grams protein per kilogram body weight. So, maybe they're consuming 140 grams of protein per day. They could get 50 from soy, 50 from whey, and 50 from a mixture of, different protein sources. So I don't really think it's a concern at all.
There is some controversy around soy formula and particularly female infants and kind of early development. Can we just zoom in on that for a moment?
Sure, and that is a controversy. I remember visiting New Zealand and Australia in 1994 because, for reasons that we don't have to go into, but it's a sort of a comical story. The controversy about soy formula actually started in New Zealand and then sort of spread to Australia. And in the early days, a lot of Australian researchers were leading the way when it came to soy research. So it's as simple to understand, at least from a theoretical perspective, conceptual perspective, why there would be a concern, because when a baby is consuming soy formula, their only source of nutrition, even though it's made with soy protein isolate, because they're getting so much soy protein, they're consuming a large amount of isoflavones, especially when expressed on a body weight basis. So Ken Setchell, I mentioned him before, in a 1997 paper in Lancet, showed just how dramatically high serum isoflavone levels are in infants relative to what they would be in adults who are consuming soy foods, because, again, adults weigh a lot more, so you express these things on a body weight basis. In 2008, the American Pediatric Academy, American Academy of Pediatrics, concluded that soy was safe, but then the National Toxicology Program in the U.S. did a review in 2006 and again in 2009. The first time they concluded that there was negligible concern about soy formula, which is the least amount of concern you can have. The next time they reviewed the data, they said there was minimal concern. And so the controversy has continued. There's work in the States at the University of Arkansas, which is a really great study, and they're following these kids who consume soy formula, breast milk or cow's milk formula, through 14 years of age. And they're not finding any adverse effects whatsoever. But there are a number of observational studies that have looked at fertility, menstrual cycle in women who were interviewed to determine how much soy they consumed when they were young. That's a difficult issue to study because it's difficult to study infants. And you can't really do a clinical trial in infants. So all you can do is identify mothers who for whatever reason, want to feed soy formula. And that makes it not a clinical trial because it's not randomized. So it's a very difficult topic to study. I know France has issued some guidelines about soy formula and infants. It would be wonderful to get some more data. And I think when the data from the University of Arkansas is published, we're going to gain a lot more insight. So I think that area remains somewhat controversial, to be sure.
And what about soy allergy? That's another thing that often comes up, particularly with infants. How common is soy allergy? Is it the protein that's causing the allergy? And I guess from a prevalence point of view, where does it rank in comparison to some of the other allergies like milk and eggs, etc.?
Yeah. So I can only reference U.S. data, but it's similar in many other countries, but not all other countries. So soy. So there are 100. So it is a protein in foods that cause allergic reactions, and there's probably 160 to 200 foods that have been shown to cause allergic reactions in some individuals. And food allergy is on the rise, and there's actually also a rise in the number of older individuals who develop food allergies. So it's a big issue, and the researchers in this field are working on ways to reduce the chances of someone developing a food allergy by early introduction of foods, such as peanuts and eggs, and soy will actually be tested for its early introduction to prevent later onset of allergy. But in terms of a comparison, we in the States have the big 8. These are the 8 foods that are responsible for 90% of the food allergic reactions. And soy is number 8. So it's of these major allergens, the prevalence is the lowest. And actually published a review a few years ago with a co-author who was an allergy expert. And we estimated, based on the surveys conducted in Canada and the US, that about 3 out of every 1,000 adults are allergic to soy. So if you're allergic to soy, it's a drag, to be sure, because soy is present in a lot of foods. People in the Western countries not Asian countries, don't eat a lot of soy, but soy is used as an ingredient for, it can extend shelf life, it changes texture, it's used as a whitening agent. So it's present in a whole bunch of foods in very, very tiny amounts. These amounts don't make a nutritional contribution, but if you're allergic, you're not going to be able to consume that food. So it's relatively infrequent. About 70% of the children outgrow their soy allergy by age 10. And so we have the big 8. Now it's actually the big 9 because sesame seed was added to the major allergen list, just like in Canada. In Europe, there's the big 14. So they have, and soy is one of those. But it's really quite infrequent. It's I think the perception out there is a lot worse than is actually the case. But I think one of the reasons that a protein like pea protein has become more popular is because it's not at the moment included in the major allergen list in the United States. It may be at some point because there have been a number of reports of an increasing incidence of allergy to pea protein. And by the way, soybean oil, which in the United States is labeled as vegetable oil in most instances, is not does not elicit an allergic reaction. So if you are allergic to soy protein, you can still consume soybean oil. And soybean oil is interesting because it does have both essential fatty acids, omega-6 linoleic acid and omega-3 linolenic acid.
I want to circle back to thyroid health. I mentioned that at the beginning. That's another aspect of health that comes up when talking about soy. What do we understand about how these soy isoflavones interact or affect thyroid hormone production and thyroid function?
Actually, there were a few instances of thyroid problems in infants who were fed soy formula in the 1960s, late 50s, early 1960s, when the formula was fortified with iodine and the type of soy protein was switched. There was no longer a concern. And then this issue rose again, mostly in the late 1990s, early 2000s, as a result of one research group in the States, again, based on some studies in animals. And they were showing that the isoflavones, so it's about isoflavones, could inhibit the activity, the activity of an enzyme that is required or involved in the synthesis of thyroid hormone, or the isoflavones itself may have the iodine put on them instead of this amino acid that needs to be iodinated. So there were a couple different ways that soy isoflavones could be having an adverse effect. But when you actually look at the clinical studies, I mentioned before in 2019, I think it was, there was a meta-analysis of 18 clinical studies, no effect of soy or isoflavones on the two main thyroid hormones. So that was a very important finding. It's not surprising, but it's important to see it in a meta-analysis. Then I mentioned there was a concern that if you were not consuming enough iodine or had a marginal intake of iodine, so it was a little bit low, and you consumed isoflavones, that it would worsen your thyroid function. That was actually looked at in a paper published in 2012. That was not a concern. And then finally, there's a condition called subclinical hypothyroidism. So you have normal thyroid function, low thyroid function, where you actually need to take thyroid medication. And then a condition in between those two extremes called subclinical hypothyroidism. And a paper came out in 2011 by British researchers, good researchers, and they showed in subclinical hypothyroid patients that soy could be a problem. It was a small study, so it did raise a red flag, but then they repeated the study and actually used a larger dose of isoflavones and found no adverse effects. So for them, as far as I can tell, the thyroid issue has been resolved as a result of all these clinical studies now that have been conducted. Again, most of the concerns about soy are based on animal studies. Even the concern about male feminization was initially based on some effects on testosterone levels in monkeys.
Does that also extend to autoimmune thyroid conditions, Hashimoto's and Graves'?
Yeah, I don't think there's any connection between the two, but that has not been studied in any kind of a clinical trial.
And people with hypothyroidism who are taking an exogenous thyroid hormone, there is this talk of trying to separate the time in which you have your medication or the hormones and the time in which you're eating soy foods.
That's correct. So there are, and they should. And it's anywhere, I look at that fairly frequently, and it's anywhere from 1 hour delay to as much as a 3 hour delay. And that's an effect not of the isoflavones, because the protein itself can inhibit the absorption of the drug. And but that's true of calcium supplements, iron supplements, a whole bunch of herbs and drugs, and food in general, because you take the medication in fasting conditions. So if you really want to consume soy, for example, at breakfast, soy milk on cereal, whatever the case may be, as long as you're consistent in the way you consume soy and the way you take the medication, that would work out as well. Because when you're with your healthcare provider, they're going to give you a dose and then look at your blood levels to make sure that they're giving you the proper dose. And if you're consistent in the way you take the medication and eat soy foods, it's not going to be a problem. If you're not consistent, then you do want to wait anywhere from 1 to 3 hours. But again, that's true of a whole bunch of things, not just soy.
Quick one. A lot of people ask me for tips on buying supplements and getting blood tests. I've created zero-cost guides for both of these, which you can download from my website, theproof.com. You mentioned earlier that these phytoestrogens are not increasing estrogen in the body. What about other hormones that are important for reproduction, fertility, like luteinizing hormone and follicle stimulating hormone?
Yeah, so in postmenopausal women, because I'm actually going through the data now for a paper I hope to publish at some point in the not too distant future, there's clearly no effect on FSH levels. I mean, there are something like 30 studies, 30 clinical studies in postmenopausal women. There was a paper published in 2009 that looked at premenopausal women. There was potentially a slight effect, a very modest effect, but the researchers actually weren't able to conclude whether it was an estrogenic effect or an anti-estrogenic effect. And when they actually looked at the higher quality studies, there was no longer effect of isoflavones on FSH levels. There was a concern that from studies done in England, initially in 94 and then 95, that soy could actually increase the length of the menstrual cycle. Those studies really got a lot of press. Aideen Cassidy was the lead author of those two studies. And on average, there seems to be about a 1 day increase in menstrual cycle length. And to my knowledge, no studies examining the effect of soy in menstrual cycle length have been published over probably the last 15 years. But if you look at the existing literature, maybe a 1 day increase. Now, longer cycles are associated with a reduced risk of breast cancer. It's a very speculative hypothesis, so it could be beneficial. I don't think it affects ovulation at all. And one thing I do want to mention that I haven't talked about so far is the role that soy may have in reducing risk of breast cancer. So I got into this field because I was working at the National Cancer Institute back in the late 1980s, and some research surfaced indicating, animal research, that soy may inhibit the development of mammary cancer, breast cancer in rodents. So I was already eating soy. I was a vegetarian, eating tofu and other soy products. I actually started eating those products because I took a lot of martial arts when I was young, and my instructor, Taiwanese instructor, said if I became a vegetarian, my martial arts would improve. Now, I think that's ridiculous, but I didn't have any nutrition background at the time. And so I got interested in soy when I was working at the National Cancer Institute. But for the past, it's almost 25 years, 26 years, my view has been that soy does reduce risk of developing breast cancer, but to derive that benefit, it needs to be consumed during childhood and or sort of the teenage years. I think it's one of the most interesting diet cancer hypotheses that have been proposed. There's quite a bit of observational support for it and animal studies. We don't really have any clinical data. We may very soon, but it seems like and it's due to isoflavones. It seems like the isoflavones are able to affect the cells in the developing breast in a way that makes them permanently less likely to be transformed into cancer cells later on in life. And if you look at the observational studies, you're seeing anywhere from a 25 to a 50% reduction in risk. So I recommend that all girls consume at least one serving of soy per day, because the observational studies suggest one serving is enough to derive this benefit. And, soy is a nutritious food. It's easy to incorporate into the diet. So, consume a cup of soy milk, or a little bit, half a cup of edamame, a little bit of ounce of soy nuts, whatever it is. I think all girls should be consuming one serving per day.
So that observational evidence, is that comparing women that consume soy early in life in Asia versus Western populations, and then looking at incidence of breast cancer? Or is it looking at comparing within a population? So within an Asian population, those who consume soy early in life and those who didn't, and then their risk of breast cancer?
It's that one. So, and that's a good general point. I don't rely on different ecological differences in ecological studies for any evidence about what soy does. I mean, certainly in the early days, early 1990s, when I mentioned that animal study was published showing that soy may inhibit the development of mammary carcinogenesis, and then we knew about isoflavones, and it was proposed in 1966 that they may function as anti-estrogens. And we also knew that the historical incidence rate of breast cancer in Japan was, and still is, much lower than in Western countries. That kind of observational data is great for generating hypotheses. But what you really care about is not whether women in Japan have a lower rate of breast cancer than women in the US or Australia or England. What you care about is whether women in Japan who eat soy have a lower rate of breast cancer than women in Japan who don't eat soy. And the observational studies to which I referred are all involving Asian populations, and they're looking at soy intake early in life. So that's a tough one, because you're talking about 50 or 60-year-old women and then asking them to recall how much soy they consumed when they were 10 years old. In some cases, you also ask the mothers of those women how much they remember their daughters consuming. It's a type of epidemiologic study that's done routinely. And I think most people can have a sense of whether they liked a particular food when they were, 10 years old.
I read an interesting study recently on soy isoflavone consumption and migraines. I'm not sure if you saw that. I think it was published a year ago out of Iran. Have you seen that study?
I did, yeah. For some unknown reason, Iranian researchers are publishing an enormous amount of research on soy. And they do reviews and meta-analysis. And I've talked to some Iranian scientists, and I said, well, you don't eat soy in the country, you don't grow soybeans. It's hysterical, because when I see a meta-analysis, I just assume that it's from Iran. It's a little bit of an exaggeration. There's looking at migraines and also depression. I actually co-authored a paper, I think it was in 2016, that suggested an inverse association with depression. So the more soy you consume, the less likely you were to be depressed. But, I think the only kind of, it's an exaggeration, but for the most part, when I'm relying on the observational studies, I look at the prospective studies. And I also, and this is a really important point, you routinely see observational epidemiologic studies looking at the effect of soy on any number of health outcomes. There were probably 5 published within the last 2 weeks from the United States. Soy is gaining in popularity, but for the most part, we're not consuming much soy in this country. So oftentimes what you see being compared is consuming 1 serving a week with no servings a week, or 3 milligrams per day of isoflavones versus a half a milligram of isoflavones. 3 milligrams, there's 25 in a cup of soy milk. There's no way that 3 milligrams consumed daily for 150 years is going to have any health effect, but you can still find associations. So I only consider the prospective studies, the kind of epidemiologic study that carries the most weight among epidemiologists. And these are cohorts who are from Asian countries or vegetarian cohorts like Epic Oxford or the Seventh-day Adventist, the Adventist Health Study 2 in this country. Because in those populations, there's a sufficient amount of soy so it's biologically plausible that soy could exert a health effect. And you also see a range of intake. So for example, I was involved in a study published in 2014 that involved Seventh-day Adventist girls, and we looked at whether soy intake affected age of menses onset, when girls begin menstruating. So it was 327 girls, and about 20% of the girls actually consumed about 4 servings of soy per day, and about 20% consumed no more than 1 serving per week. That's exactly what you want to find in a study like that, a range of soy intake. Plus, they were all Seventh-day Adventists, so it's a very homogeneous population. So normally, if you're a Westerner and you're consuming, 2 servings of tofu per day, there's a really good chance that you're going to be different from your neighbor who's not consuming tofu in ways beyond just soy consumption. You might be meditating and running marathons, who knows? And while scientists try to adjust for those potentially confounding differences, of course, it's not possible to do that 100%. So Seventh-day Adventist population, I think, is a really good one to study because it's so homogeneous. Most of them don't smoke. They go to church on a regular basis. So that's a nice population. We didn't see any relationship between soy intake among the girls and age of menses onset.
For anyone who's interested in that migraine paper, I'll put that into the show notes. But it gets me thinking, because in that RCT, they used a soy isoflavone supplement, and we haven't spoken about that yet. I think they used 50 milligrams a day, and they actually reported some reduction in migraines and the duration of the migraines. But on soy isoflavone supplements, what's your view on those and the safety and the efficacy?
If you believe that the outcome of interest is affected by isoflavones, then I think supplements are absolutely the way to go, because the experimental design is a lot cleaner. You're not disturbing the overall content of the diet. The participants are going to be blinded, and compliance is going to be much less of a concern. And the absorption and metabolism of isoflavones from pills is the same as it is from soy foods. So, if you're doing a hot flash study, the participants have to be blinded. So you really need to use isoflavone supplements. So it's really a good way to go. Now, if you're not sure about the component in soy that may be responsible for a proposed health effect, then of course you want to use the food. Now, from a dietary perspective, of course, I want people to consume soy foods, because as we talked about before, not only does soy have a lot more going for it than just isoflavones, but it's also that displacement effect. Hopefully if you're consuming a soy food, maybe it's in place of something that's less healthful. So from an experimental standpoint, if you think isoflavones are responsible for benefit, go ahead and use the pills. Now, for like cholesterol reduction that we talked about before, that's a protein effect. So obviously the pills would not work. Let's
finish here on agriculture and the environment. I'm sure you get asked a lot of questions about this. I think when soy comes up, inevitably people point to genetic modification, the use of herbicides like glyphosate in farming, and there's a lot of fear generated around that. Do you have a view on this and whether people should look out for non-GMO, organic, etc. on packaging or not?
I think there's no difference whatsoever from a health nutritional perspective. Now, in the States, we have a lot of foods made from organic soybeans. So if you are concerned about genetic modification, then sure, go ahead and buy the foods made from organic soybeans. But I haven't seen any evidence that there would be a difference in terms of health effects. So I think glyphosate is safe. The herbicide is safe. I know that's controversial, but from what I read, my interpretation of the data is certainly that it's very safe. I think most of the concerns come from people who might be applying the herbicide, the actual workers who are applying the herbicide, but that's different. So, I think as long as we're talking about the environment, I do think that it's worthwhile. It's way outside my area of expertise, but I think it's pretty clear that soy foods have a low environmental footprint. If you compare a soy burger with a hamburger or cow's milk with soy milk, soy does very well. And in fact, out of the paper published by Gonzalez and colleagues in 2011, looked at 22 different plant and animal sources of protein. And they found that growing soybeans was the most efficient way to produce protein, and it resulted in the fewest greenhouse gas emissions when expressed on like a per gram protein basis. So I think there's also a good environmental story. And the farmers in this country have done one heck of a job in growing soybeans more sustainably. It's amazing. The yield has increased. They have no tilling. The amount of fertilizer they used has decreased. And that's one of the nice things about soybeans is they fix atmospheric nitrogen, so you don't really need much or any fertilizer. But the farmers have done an amazing job growing soybeans in this country, very, very efficiently and sustainably produced. So, to me, it's just another reason to consume soy foods.
That seems, I think, at odds with what the average person, if you say you went onto TikTok today or Instagram, and we went around and we asked people whether soy was good or bad for the environment and what their thoughts were, I think a lot of people immediately will think about the Amazon burning.
Absolutely.
And being deforested.
Deforestation, yeah. And that's true. But as you know, those soybeans are being grown for animal feed. They're not being grown for tofu. So if you just look at tofu production, the beans are efficiently produced because soybeans are higher in protein than other beans. They have a lot of advantages. And then even when you go from the soybean to like soy protein isolate or tofu, those foods compare very, very well to their animal-based counterparts.
Right. Yeah, I think the latest stat that I've seen is 75% of that soy produced in the Amazon is for animal agriculture, and then there might be about 15 or a bit more percent going to biofuels, and that leaves a small chunk for direct human consumption.
Yeah, I would agree with that for sure.
Well, Mark, Thank you so much. This has been super interesting. Before we wind up, was there anything else about soy that we perhaps missed or you wanted to kind of cover?
Well, thanks again for this opportunity. I enjoyed it. I would just say, if my personal intake recommendation is about 2 servings per day. Try to find there are a lot of soy foods out there, soy nuts, edamame, tofu, soy milk. Try to find a couple of foods that you enjoy and try to eat 2 servings per day. 2 is better than 1, and 1 is better than none. It's at the very least, it's got an excellent nutrient content, macronutrient, micronutrients, and it's a very versatile food, environmentally friendly. So I think it really should be part of everybody's diet. And because there's so many different foods that can be made from the soybean, I think it fits with just about all cuisines. What
are your favorites, your soy go-tos?
Tofu, soy milk, and tempeh. So I eat about 2 servings of soy a day, and I also eat a lot of soy burgers because my cooking skills are pretty much non-existent, and I'm amazed. My wife's an excellent cook, and she's a dietitian, has a master's degree, an expert in vegan nutrition. She loves to cook, thank God, because I love to eat. It works out really well. But for me, I'm a microwaver, and a lot of the soy burgers you can microwave, and a minute later I have something that I enjoy a lot, and it's going to give me 15 grams of protein, so it's a wonderful snack. So I eat those on a regular basis. I'm a big promoter of beans in general, legumes in general, black beans, pinto beans. We eat beans all the time, but I probably don't eat beans 3 times a day. So I think some of those convenient foods really, really come in handy. And some of the foods like the Impossible Burger are fortified with shortfall nutrients in plant-based diets, so they can also be excellent sources of some of these nutrients that are harder to get, like iron and zinc.
Yeah, I think plenty of the listeners will recall Jenny. She was on the show, I think maybe a year or so ago. It was a very, very popular episode. So perhaps if they haven't listened, they can go back and check that one out. All right, Mark, thank you so much. I'll put a link to your Google Scholar page in the show notes so people can look that up and look at the various papers that you've published. Are there any other resources that you'd like me to share with the listeners if they want to know more about what we've discussed today?
Yeah, I would say just Google the Soy Nutrition Institute. I write a blog post every couple of weeks. There's a lot of interesting fact sheets. And you can also reach me via that website. So just Google Soy Nutrition Institute. I think it's a good place to start.
Thanks for your time today and the dedication to science and science communication. I learned a lot.
Thank you.
There we go, friends. Thank you for showing up and the effort you're making to take better control of your health. I look forward to hanging out with you again next week for another episode.